All right, let's talk about shapes. We're going to go on a little journey today to find the simple, beautiful logic that connects all of them. We're looking for the master key that opens up everything, from a basic triangle all the way to a perfect circle. So let's get into it.
We're going to start right here, with the most fundamental shape there is, the triangle. 3 sides, 3 corners. Seems almost too simple, right? But then, how does that simple little triangle help us make sense of, well, this thing? A dodecagon with 12 sides. They feel like they're from completely different worlds. And that's our big question for today. How can this one humble shape, the triangle, actually hold the secret to understanding all the others, no matter how ridiculously complex they get?
Okay, first things first. Let's get our language right. We're kicking things off with shapes that have straight sides. You probably know them as the basic building blocks of geometry, polygons.
So what is a polygon, really? It's just a fancy word for any flat shape that's completely closed in by 3 or more straight lines. Think about it. A triangle, a square, a pentagon, they're all just members of this big polygon family. And no matter how many sides they have, they all share the same basic parts. You've got your sides, the lines themselves. You've got vertices, that's just the corners where the sides meet. And then you have angles. The one on the inside is the interior angle, and if you imagine extending one of the sides straight out, you create an exterior angle. Now here's the key rule, and you're going to want to remember this. An interior angle and its outside partner always add up to a perfect 180 degrees.
And now we get to the really cool part, the triangle's magic trick. It gives us one single number, one rule that just explains everything else.
And here it is, 180 degrees. This number, right here, is the absolute bedrock for understanding what goes on inside every single polygon.
Because here's the thing, it doesn't matter what the triangle looks like. It could be long and skinny, short and fat, perfectly balanced. You add up its 3 inside angles, and the sum is always 180 degrees. No exceptions. This right here, this is our master key. So, we've got the key. Now, let's go use it to crack the code for all those bigger, crazier shapes we saw a minute ago.
I mean, it's great that we know a triangle is 180 degrees, but how does that help us with a pentagon, or an octagon, or anything else for that matter?
Well, watch this. A really cool pattern shows up if you just start breaking these shapes down. Pick any corner on a polygon and just draw straight lines to all the other corners. A 4-sided quadrilateral? It splits into 2 triangles. A 5-sided pentagon? That splits into 3. You see in the pattern here? The number of triangles you can make is always 2 less than the number of sides.
And that simple little pattern gives us this beautiful, simple formula that works for any polygon you can imagine. To get the sum of all the inside angles, just take the number of sides, n, subtract 2 from it, and multiply that by 180. That's it. It works every single time. Okay, so we've got the inside of the shape all figured out, but what about all those exterior angles on the outside? You'd probably expect another complicated formula for that, right? Nope, it's way simpler. It's always 360 degrees. I don't care if it's a triangle or a shape with 100 sides. If you imagine walking around the perimeter of the shape, the total of all the little turns you make at each corner will always bring you back in a full circle, 360 degrees.
You know, that whole idea of making a full 360-degree turn is the perfect way to pivot to our next shape. A shape that is basically one single continuous turn. Let's talk about the perfect curve, the circle.
So, what is a circle? It's just all the points that are the exact same distance from one single point in the middle. And just like polygons, it has its own anatomy. An arc is just a piece of the curvy edge. A chord is a straight line that connects any 2 points on that edge. And a sector, well, that's your classic slice of pizza, defined by an angle right at the very center of the circle.
Now, to measure anything about a circle, we need a very special, almost magical number. I think you know what I'm talking about, pi. That little symbol, pi, is the key that unlocks pretty much everything about circles. And with pi, we get these 2 powerhouse formulas. The distance all the way around the circle, its circumference, is just 2 times pi times the radius, and the total space inside it, the area, is pi times the radius squared. These 2 are the absolute foundation for measuring circles.
But that's for the whole pie, right? What if you just want to measure one slice? How do we figure that out?
Well, the logic here is actually super intuitive. A slice, or a sector, is really just a fraction of the entire circle.
and that fraction is totally determined by its angle at the center. A full circle is 360 degrees, so a sector's angle tells us exactly what piece of the whole thing we're looking at.
So all we have to do is tweak our original formulas. To find the length of the crust on our slice, the arc, you just take the full circumference and multiply it by that fraction, the angle x divided by 360. And for the area of the slice, you guessed it, it's the full area times that exact same fraction. Simple.
But hang on, here's one last really interesting little detail. The length of the arc and the area of the sector are perfectly proportional to that central angle. If you double the angle, you double the arc length, you double the area. But look at the chord, that straight line cutting across. Its length is not proportional. It doesn't double. It's a subtle but really cool reminder that taking the scenic, curved route is very different from cutting straight across.
So we've seen how one simple rule for a triangle unlocks the secrets of every single polygon, and how the simple idea of a fraction unlocks how to measure any part of a circle. It really makes you stop and wonder, doesn't it? If a simple triangle holds the key to all polygons, what other simple ideas are just waiting out there to unlock the complex world all around us?